right, students out there, this is the verifications that you guys were working on yesterday, hopefully working on yesterday. I understand that some of them were quite hard, so I'm going to kind of just let you look through some of my worked out answers and see if maybe you could replicate something similar. So here's number 21. Naturally, I worked on the toughest looking side, the left side. You could see the numerator, the sine of 2 theta, changed into 2 sine cosine. This denominator, I took this cosine 2 theta and replaced it with one of the versions, 1 minus 2 sine squared theta. Of course, the other ones will work a little differently, but still work. And distribute the minus, and you get the ones to cancel. And once everything's canceled, you get the 2's and the sines canceling, and you are left with nothing but cosine or sine, which was the cotangent, which is the right-hand side. Number 22. Very similar. The numerator has only one way to go. And the denominator, if you split that up into sine 2 theta plus 2 theta, because those two add up to 4 theta, then you can do, I'm choosing to do something different here. I'm using a double angle of a double angle, and this is what it looks like. Now, do I expect you to do that? I probably expect you guys to treat this as U and treat this as V and do the sine of U plus V at that point. And that works out the same way, and you end up getting the right-hand side, which is 1/2 secant of 2 theta. All right, so you can pause and look at these solutions at any time because you guys have video. All right, number 23. I didn't hear too many complaints about this one. This one looks like DOP, so you just factor into a difference of perfect squares. And this particular piece is 1. And this is actually the double angle formula off of the formula sheet, and it takes you right to the answer. Number 24, again, I think most people were okay. They literally foiled this out. And you can take this piece combined with this piece. I just rewrote them together because these two form 1. And it's minus this, which again is on the formula sheet. That is sine of the double angle 2x, which is the right-hand side. All right, so then number 25 was a skip because I think we did that as a class example. All right, so if you're interested in trying it, go ahead. Number 26. This is what I'm thinking. Kind of a tough question, but I still do the same thing. I take 3x because there's no triple angle formula, and I split it into x plus 2x. The denominator, again, there's only one opportunity for that. Then I treated this as U and treated this as V, and I did the sine of U plus V formula from earlier in the week or last week. You can see that I'm splitting this up. Okay, so this right here over top of this is here, and this right here over top of the denominator is right here. That allows for some canceling, the sine x's and the cosine x's, leading us to something that looks like this. In which case, I'm going to use a double angle formula off of the sheet to change cosine 2x to this. And sine 2x, again, can only become this. This particular fraction has two things on top, one on bottom. This can be split again itself. So you're going to take 2 cosine squared x, put it over 2 cosine x, and take the 1 over to 2 cosine x, and you can see that that fraction is now split. That allows for some more canceling. you end up with a cosine x from this. This is 1/2, and that's the 1 over cosine, so that gives you the secant x. And you're left with another cosine x. So if you take a close look, you got a cosine x and a cosine x, which is 2 cosine x. And then you still have the minus 1/2 secant x, which is the right-hand side. So 26 was pretty tough, but maybe you should try to walk through it one more time, see if you can do it. 27, probably the toughest. Let's see, where is that? Okay. All right, so this is the first time that you got to see tangent involved, and I think that was probably intimidating. So take a look. If we just work on this side, sine of 2a, there's only one thing you can do, and I think most of you guys got that. But this is tan of a, but it's not a double angle, so it's just a regular tangent. So we're just going, that means sine of a over cosine of a, and we're going to say, hey, these things need to be together as one unit, so you need to get a common denominator. So this fraction needs a cosine in its denominator, so you introduce a cosine on the top and bottom. Therefore, that would become the cosine squared, and then it would have a cosine in the denominator. So that's what really happened. These two go together as a single fraction. And once you got them together as a single fraction, you can factor a sine of a out of the top, and that leaves you with 2 cosine squared a minus 1, and that should look familiar, the parentheses part. That's a double angle formula. So you literally have sine of a over cosine of a, which is tan, and then you have this double angle formula, which you substituted from the formula sheet, cosine of 2a, and that, my friends, is the right-hand side. Okay? And I think that was the assignment. I don't believe you had to do number 28 or anything past that. So that's it for verifying identities again. The next lesson is going to be solving trigonometric equations. I'm getting ready to produce that. So have a nice day, and I'll be back with you in a bit.